variations of voltage V and current I for different circuit elements. The first one, ohmic conductor. For examples, consider a copper wire. From experiment, we know that the voltage against the current I. In the graph, it is a straight line passing through the origin, which means that the voltage is proportional to the current. In this case, the slope of the graph is V over I, which is constant value. And the slope is defined as the resistance of the wire. Therefore, for ohmic conductor, the resistance R equal to V over I, and the resistance is a constant value. That means the resistance of ohmic conductor is independent of I and V. What are the factors affecting the resistance of a wire? Consider the wire of length L and cross-sectional area A, and ρ is the resistivity of the medium. If this is copper wires, then ρ is the resistivity of copper. Okay, if this is an iron bar, then ρ is the resistivity of iron, etc. It is found that the resistance of a wire is equal to ρ L over A, which means that for a longer wire, the length increases and the resistance of the wire also increases. Next, for a thicker wire, that means the cross-section area of the wire increases. In this case, the resistance of wire will decrease. The last factors affecting the resistance is the resistivity, which depends on the material. The unit of resistivity, ρ, is ohm meter. Consider a variable resistor, or we say a rheostat. In the figure, the rheostat is connected to a circuit as shown with the circuit diagram here. When the switch is closed, the current flows through the circuit and the ammeter registers a current I. If the sliding contact S is moved towards B or C, then the current will pass through a longer distance of resistance wires before it goes to the ammeter. Because the length of the resistance wires increases, therefore the resistance of the circuit also increases. Therefore, the current in the circuit will decrease. Hence, a variable resistor or rheostat is often used to adjust the current I in the circuit. The second circuit element to study is the filament bulb. Inside a filament bulb, the filament wire is made of tungsten wire, which can resist high temperature. First, a small current I, that is at low temperature, V proportional to I, and the slope, that is the resistance of the wire, is small and constant. At large current, the temperature is very high. and the resistance of the wires increases. In this case, we say the voltage is no longer proportional to current. For electrolyte 電解質 one kind of electrolytes, the VI graph, is a straight line passing through the origins. That means it obeys Ohm's law with constant resistance. Another kind of electrolyte, the VI graph, is something like this one, which means that V does not proportional to current. This kind of electrolyte does not obey Ohm's law. For another kind of circuit elements, the diode 二極管, the VI graph is again which is not proportional. That means V is not proportional to current. The last circuit element to study is semiconductor 半導體, or we use thermistor. Thermistor is a device made up of semiconductor. For a thermistor, the VI graph is something look like this one. When the current is small, the temperature of the thermistor T is also small, but the slope of the graph, which is equal to the resistance of the thermistor, is high. However, when the current increases further, that means when the current is high, the temperature of the thermistors will also increases, which is high, but the slope of the graph decreases, which implies that the resistance of the thermistor also decreases. Or we say the resistance will be low. Therefore, for a thermistor, when the temperature is high, the resistance is low. However, when the temperature is small, the resistance of the thermistor is high. As a result, we see that the graph of resistance against temperature is that the resistance of the thermistors drops when the current increases or when the temperature increases. This relation is completely different from that of a filament bulb.